Okay, so today we're going to be doing something a bit different. I'm going to be working through the tutorials on learnopengl.com. Something I've been meaning to do for a little while, a few months, because I mean, I'm a game programmer and I've made games with Unity and XNA, and well, that's basically it. But I don't really know the low-level stuff too well, like the OpenGL layer, the DirectX layer. So yeah, I was just thinking, go through these tutorials and maybe because they're actually pretty difficult, the tutorials. Um, so I was thinking maybe people would like to watch someone actually go through them and see how to get the environment set up and all that sort of stuff. So this introduction is just all text, so I'm probably I will skip it. We're gonna go to OpenGL, I believe. I think this is also all text. It tells you a bit about OpenGL and some other stuff. This looks like code samples, but they're just kind of excerpts to explain things to people. So we're going to start here, actually, in creating a window. So the first thing we need to do is to create Southern Graphics is create an OpenGL context and an application window to draw in. However, those operations are specific per operating system, and OpenGL purposefully tries to extract these from these operations. This means we have to create a window, define a context, and handle user input all by ourselves. So basically, OpenGL is only responsible for graphics, and the rest of the stuff is OS layer stuff, and you have to do that yourself. Luckily, there are quite a few libraries out there that already provide the functionality we seek, some specifically aimed at OpenGL. Those libraries save us all the operation, system-specific work, and give us a window and an OpenGL context to render in. Some of the more popular libraries are Glute, SDL, SFML, and GLFW. For our tutorials, we're using GLFW. When I was at university, we actually used Glute. I can't remember what that stood for. SDL, I think, is the Linux version. I don't know, actually. I think it's popular on Linux. I remember watching somebody's tutorials and he was doing that in Linux. So GLFW. GLFW is a library written in C, specifically targeted at OpenGL, providing the bare necessities required for rendering goodies to the screen. It allows us to create an OpenGL context, define window parameters, and handle user input, which is all that we need. The focus of this and the next tutorial is getting GLFW up and running, making sure it properly creates an OpenGL context and that it properly displays a window for us to render in. The tutorial will take a step-by-step approach in retrieving, building, and linking the GLFW library. For this tutorial, we will be using Visual Studio 2012. Actually, we're going to use 2013 because it's free. If you're not using Visual Studio or you are using an older version, don't worry, the process will be similar on most other IDEs. Visual Studio 2012 or any other version can be downloaded for free at Microsoft by selecting the Express version. Yeah, so now I'm going to be using Visual Studio 2013 Community Edition. Community 2013. It's totally free. So, and it's exactly for this sort of stuff. Just messing around, non-commercial applications. I don't know what GLFW stands for, so I guess we should look that up, right? I mean, GL is probably graphics library, and it's probably just short for OpenGL. I mean, it doesn't even tell us, right? Look at this. You wouldn't have this, like, this line. Hey, if you don't like it, use something else. You wouldn't have this on, like, Facebook.com or Twitter.com. It's fucking open source projects. This is pretty cool. I don't know how they calculate that. So I guess they're on 3.1, 3.11. And they're saying, oh, yeah, it's 4% done. Documentation. I still don't know what it means. I mean, what it stands for. FAQ. What is a GLFW? Small library. Still nothing. And for acronym. What does GLFW stand for? Yeah. Oh, framework. Is it? Graphics library framework? Yeah. OpenGL framework. Makes sense. We could have figured that out. That's really good because, yeah, okay. Actually, I'm going to turn these videos into little YouTube clips, and I'll probably cut that sort of section out because people don't really want to know that. Or maybe not. Maybe I'll just keep them as long and stupid videos. Yeah, okay, so GLFW can be obtained from their website's download page. GLFW already has precompiled binaries and header files for Visual Studio 2012/13, but for completeness sake, we will compile GLFW ourselves from source code. So let's download the source package. Yeah, so this is pretty cool. I mean, this is something I've never done before, actually. Well, I guess I have, but I mean, I haven't done it. Yeah, whatever. Let's just say I haven't done it before. So we're actually going to download the source code of GLFW since it's open source. And then we're going to use a utility called CMake to build it. And then that's going to output, I believe, a Visual Studio solution. Then we open this Visual Studio solution, and then we build it. And then that's going to output a .lib file, which is like a C++ library file. It's like 2 steps. Download, well, it's a lot more steps actually. It's download source, compile with CMake, open Visual Studio project, build. It's 4 steps. It's not too bad. You don't actually need to do that, as they actually say GLFW already has precompiled binaries and header files. But it's kind of nice to know how to use CMake, and it's kind of nice to know how to build libs from source. I actually really enjoyed this part of the tutorial because I've never done it before. And it's just one of those things that's good to know, because somewhere along the line you'll come across you just need to know this sort of stuff. I mean, even harder tutorials, or just tutorials with less explanations, you go through it and it says, yeah, compile from source, and you don't know how to do that. You download the source, that's easy, and then you see all these files and you don't know how to compile it, right? Anyway, once you download the source package, oh, we need to do that. Okay, let's get the source package. So I actually did all this yesterday, and that means I've got, I cleared out the project, but there might be some stuff lingering around. I tried to clear out as much as possible, but some stuff is still around somewhere. Yeah. Is this streaming? Better be. Yeah, it is. Cool. Conversion is March 19, source package. So I guess we're going to get 3.11. OpenGL framework. My friend is a big C++ guy, and he makes all his games with C++, even Android games and iOS games, and he uses something that sounds like pizza or something. I don't know what he's using, but he's using basically a C++ game development framework. I see the internet's pretty slow. I think it's probably because we are streaming. That's a bit annoying. I should have pre-downloaded all this stuff. It's not even in my trash. I would open it, but there might be something incriminating in there. And I'm pretty sure I deleted it, so I'm not going to go into the trash. That is really slow. Does that make it faster? Clicking twice? It did. Wow. Good tip. It's a good tip, guys. It takes long to download. Click again. Okay, cool, we got it. So we want to just grab this, extract it like that. If you guys are wondering if you should pay for WinRAR, never, ever pay for WinRAR. That is not the way we do things. Yeah, extract and open its content. We're only interested in a few items. The resulting library from compilation, the include folder. Compiling the library from source code guarantees that the resulting library is perfectly tailored for your CPU/operating system. The luxury. Oh, these luxurious pre-compiled binaries. do not always provide. Sometimes precompiled binaries are not available for your system. Oh no. The problem with providing source code to the open world, however, is that not everyone uses the same IDE for developing their application, which means the project/solution files provided may not be compatible with other people's IDEs. So people then have to build their own project solution with given CC, which is cumbersome. Especially for those reasons, there is a tool called CMake. CMake came out ages ago. CMake came out in the 70s, I believe. Yeah, CMake is a tool that can generate project solution files of the user's choice, e.g. Visual Studio, code blocks, Eclipse, from a collection of source code files using predefined CMake scripts. This allows us to generate a Visual Studio 2013 project file from GLFW source package. First, we need to download and install CMake that can be found on the download page. I'm not going to do that because I already have it. I was going to uninstall it and reinstall it so you can see everything at the start, but download speed is low, and that's just going to waste time. And the other problem is this thing took a long time to install, actually. I double-clicked and it took about 2-3 minutes for the installer to start. So if that happens to you guys, I mean, just be patient. Once CMake is installed, you can choose to run CMake from the command line or via their GUI. Since we're not trying to overcomplicate things, I mean, we are building from source. You are kind of overcomplicating things. We're going to use the GUI. CMake requires a source code folder and a destination folder for the binaries. As a source code folder, we're going to choose the root folder of the downloaded GLFW source package, and for the build folder, we're going to create a new directory called build, and then select that directory. Okay, so this is the root folder, so we just want to set this. They said we want to make a build directory, which is just where we're going to output all the stuff, which is where CMake is going to output its stuff. And in CMake, there's, I mean, these are a bunch of rules. So on these processors, do this. I don't know what this is. I686. Like, so we can just kind of look at it and yeah, it's human readable, but I mean, it looks like it's setting a bunch of environment variables or something. I don't know. CMake lists. I don't know what this is. We don't have to know what it means, and because we're not contributing to GLFW, and even if we were, we still might not have to know what it means. But CMake files are like a different sort of thing, so let's not go too deep into that. That's just going to confuse the shit out of me. Okay. Yeah, so let's open, so basically once the source and destination folders have been set, click the configure button. Let's go do that. We'll open CMake now. So CMake, where's the source code? Look at this GUI. It's very like, yeah, let's clear this out. So this is what you guys should see when you start. So this GUI is very like Windows 3.1. There's lots of buttons. Buttons are two different things. This one's got an icon for some reason. The name's RC3, release candidate 3. It's totally like a tool for a software developer. So this is the root directory. It's just desktop, this guy that we just extracted, so we choose that. And we want to build the binaries to the build folder inside there, which is just desktop glfw build, right? Okay, back to the script. Once the source and destination is set, click the configure button so CMake can read the required settings and the source code. We have to choose the generator for the project, and since we're using Visual Studio 2013, we will choose Visual Studio 11. CMake will then display the possible build options to configure the resulting library. We can leave them at their default values, so don't change anything, and then click configure again. So we click configure, and we choose something, and then we click configure again. It's like a very weird user interface. It's already scary because there's a lot of input fields. If we just open this, like I might not be able to figure out how to do it. I mean, there's configure, generate. We have to press this twice and then press this, and then click generate, and the resulting project files. But luckily, it just seems to work pretty well. So we just go configure. We want Visual Studio 12, 2013. I believe it's just the Win32 version, so we'll just choose this one. I didn't realize it was an ARM version. Yeah, I mean, just default native. It's fine. Finish. It's funny, you press finish, but that doesn't actually finish anything. Okay, so as it says here, we press configure and then configure again. We can leave their default value. So these can be changed if you want. Yeah, so we could toggle that or whatever, but we don't really know what we're doing. And since this guy says just leave at default, let's just leave it at default. So press configure again. That's done, and then next we want to click generate, and then it's done. Okay, so if we go into this folder, glfw, and we look at the build, there's some stuff, right? And we want to double click on this and open the Visual Studio project, but let's just read it so you guys know I'm not making it up. In the build folder, a file named glfw.sln can be found, and we open it with Visual Studio 2013. Since CMake generated a project file that already contains the proper configuration settings, we can hit the build solution button, and the resulting compiled library can be found in source debug, named glfw3.lib. Note we're using version 3. Once the library is generated, we want to make sure the IDE knows where to find the library, and we include files. There, yeah, that's the next part. So let's just go up to here. It's a good thing I did this yesterday. If not, like, I'd have to read this and think, what the hell is he talking about? And anyway, so let's just close that. It's not, nothing's open there anyway, and we are gonna click on this solution file, and that's open. We can kind of look at some stuff if we want. Yeah, it looks very. These are examples, are they? I don't know. Yeah, I guess they're examples. So we've got examples tests. Install, CMake rules. Anyway, we can. Oh, okay, so those are examples of tests, and this is like the main. This is the actual library. Where's the main file? Win32 init. It's pretty scary looking code. I mean, it means nothing to me. This looks like configuration, right? But it's in a C++ file. No, I'm not gonna criticize it because I don't really know shit about C programming and C++ programming. Set sticky keys mode for the specified window. Set sticky keys. Window. Enabled. If window.sticky keys is enabled, return. Oh, so if it's already set like that, then we're already done. Just get out of here. So, see, we get it. If not enabled, yeah, I don't really know what sticky keys are. I know if you press shift a bunch of times, this thing comes up. I don't know what it is. We can find that out later. This was also a bit of a side tangent that we didn't really need to go into, but I mean, it's quite fun to look at other people's source code, especially when it's scary. But we kind of understood some stuff. It wasn't that scary, was it? So we're just gonna go build solution, and then look at all this fun stuff. 20, 30, 32 equals build 30 succeeded. Skip 2. You lazy fucking compiler. Okay, so where is the library? And it's probably in debug, but according to the tutorial, it just actually tells us that it's in source debug. So actually, it's not in debug; it's in source debug, and there's the library. That's all we did. We just went through all those steps just to make this guy. So I mean, let's just put him here. This is our handmade lib file. How big is it? 376 kilobytes. It's considerably smaller than this project. How big is this? What? 86? Why is that so big? Is it the bins? Is it the build stuff? Yeah, it is the build stuff. Where's the big stuff? What is this? What's an SDF? What else is big? Who cares? This maybe docs or something? I don't know. Okay, so we got that, and then we got some more reading to do. Once the library is generated, we need to make sure the IDE knows where to find the library and the include files. Oh yeah, we also need the include files. I don't really get libraries in C and C++. I mean, you have this, and then you also have to give it include files, basically header files. Yeah, actually, let's just put it out like this. So these guys basically say, hey, these are all the functions that can be. They define a bunch of macros and shit, and they also say this lib has got this method in it. It's also got this method in it. It's also got a lot of methods in it. It's got documentation as well. So I don't know what they're exactly for. I don't know why you can't put that in here, but apparently you can't. It's got to be separated. It's C++. I mean, I vaguely know it, but I've never really worked at a company where I've written C++, and I don't do any C++ programming at all. So I had to learn it at university, but I didn't go too deep. I just kind of learned what I needed to know. So now we're doing that. Yeah, so once the library is generated, we need to make sure the IDE knows where to find the library and the include files. There are two approaches. This is the wrong approach. We can just read it out, but we find the lib and include folders of the IDE compiler and add the content of the GLFWs include to the IDE's include folder and similarly add to the. So it's basically Visual Studio has a lib and include folder, and then we just jump in there and put this lib in the lib and this .h in the .h. Actually, I don't find that so horrible, but this guy clearly does. Where in Hong Kong are you from? Oh, it's deleted. Hey, man. Good to see you. Hong Kong's not that big, so I just live in the west side of Hong Kong Island. Hong Kong's small. Yeah, so yeah, we're just going through a tutorial this time. Deleted. It's good to see you back. The recommended approach is to create a new set of directories at a location of your choice that contains all the header files / libraries from third parties to which you can refer to using your IDE / compiler. I personally use a single folder that contains libs and includes folder where I store my library. So basically, put it in the IDE's lib and include folder, or make your own and then include it per project. And I do like his method better. The reason is if you use multiple IDEs and whatnot. So I'm just going to call this folder C++. I don't know if this is a great name. And then we have includes, which is where we put the header files. Include. I might call it includes. And then libraries. And typically, actually, people do it like this. So we know this is the GLFW include folder. We get rid of these, and then the libs in there, right? So it's kind of nicely organized. Libs includes GLFW C++. Cool. So that was just C drive C++. Yeah, okay, first let's open up Visual Studio and create a new project. Choose Visual C++. Let's close this guy first. We'll close CMake as well, we're done with him. We can... Where is this? I think we can kill this. But actually, let's not. I would normally kill it, just to keep my desktop clean, but we might want to refer back to it later for some insane reason. So... First, let's open Visual Studio and create a new project. Choose Visual C++ if multiple options are given. And take the empty project. Don't forget to give your project a suitable name. We will now have a workspace to create. So make a C++ project, give it a name, and then make it an empty project. Easy. Visual C++, empty project. There it is. You should get this in Visual Studio 2013 community. You don't need any extra stuff. And then we will call it learn OpenGL. create window. Makes sense. And then we'll just go. Okay, so we got nothing. If we try to build, some sort of error. Doesn't matter. It's basically we don't have a main. I believe that's probably what it is. There's no main file. It doesn't know what to do. Linking. In order for the project to use glfw, we need to link the library with our project. This can be done by specifying we want to use glfw3.lib in the linker settings. But our project does not know where to find glfw.lib, since we pasted our third-party libraries to 2 different directories. We thus need to add those directories to the project first. We can add those directories where Visual Studio should search for libraries/include files by going into the project properties, right-click the project name in the Solution Explorer, then go to VC++ directories, as can be seen in the image below. So we go like this, properties, VC++ directories, include directories. Is that right? Yeah. From there on, you can add your own directories to let the project know where to search. This can be done manually. This can be done by manually inserting it into the text or clicking the appropriate location. Yeah, so basically we just need to say those directories that we made, we need to add them to the include directories for this project. And the thing is, the annoying thing is, every time we do a project, we need to do that. If you forget to do it, you're going to get... nothing's going to work if you forget to do it. So we'll do it like this. We just do it the IDE way. I might have clicked a bit too fast, but it's going to be on YouTube. Just watch it slowly. C++. What was this one called? Include directory. So it just includes and select this folder. Okay. Yep. And then library directories, same sort of thing. Edit. This guy. Back to my computer. This PC. C++. Libraries. Select folder. Okay. Right, and that's good. Here you can add as many extra directories as you like. From that point, IDE will search all those directories. You will also be able to find header files by including glfw same classes library directories. Since Visual Studio can now find all the required files, we can finally link glfw to the project by going into the linker tab and selecting input. So we need to do some more setting stuff. Hey Sufyan, what's up? Sorry guys, I'm not really watching chat this time because I mean, if you have questions, just stick around and I'll answer them when I'm done. We should be done pretty soon, maybe in about 20 minutes. To then add the library, you have to specify the name of the library to the linker. Since the library name is glfw.lib, we can just add that to additional dependencies field either manually or using the edit option. And from that point on, glfw will be linked when we compile. Aside from glfw, you should also add a link entry to the OpenGL library, but this might differ for operating systems. Yeah. So we go down to linker and input, I believe, additional dependencies. We're going to add gl, what's it called? glfw3.lib. glfw3.lib. And we separate them with semicolons. If you're on Windows, the OpenGL directory, opengl32.lib, comes with the Microsoft SDK, which is installed by default when you install Visual Studio. Since this tutorial uses the VS compiler and is on Windows, we add opengl32.lib to the linker settings. So we're going to add that as well. OpenGL32.lib, done. Apply. Yeah. On Linux, you need to link to the libgl.so library by adding It looks harder, right? It looks a lot harder in Linux. What a pain in the ass. Okay, so GL framework is done. We're still not quite there yet, since there is one other thing we still need to do. Since OpenGL is a standard / specification, it is up to the driver manufacturer to implement the specification to a driver that the specific graphics card supports. That was a mouthful. Since there are many different versions of OpenGL drivers, the location of most of its functions is not known at compile time and needs to be queried at runtime. It is then the task of the developer to retrieve the location of the functions he/she needs and stores them in a function pointers for later use. Retrieving those locations in OS specific and in Windows, it looks something like this. Define the function's prototype. Type the void. This GL underscore generate buffers. GL size I. GL uint. Pointer, find the function and assign it to a function pointer. GL buffers GL gen equals GL gen w get proc address. Function can now be called as not GL uint buffer. Yeah, so basically it's like you have this prototype and then you call this wgl get proc address, this thing, which is like stringly typed, and then you call him like that. So if you want to call this stuff, before you do that, you have to run these two messy lines of code. So that's a real pain in the ass. As you can see, the code looks complex, and it's a cumbersome process to do this for each function you might need, and that is not yet declared. Thankfully, there are libraries for this purpose as well, where glue is the most popular and up-to-date library. So the long and short of it is we're going to be using glue. GLUE stands for OpenGL Extension Wrangler Library. What the fuck was the L? Really? OpenGL Extension Wrangler Library. Surely it should be GLUE. It manages all that I said cumbersome 3 times in his tutorial work we talked about. Since glue is again a library, we need to build / link it to our project. Glue can be downloaded from the download page. You can either choose to use their precompiled binaries if your target platform is listed, or compile them from source as we've done with GLFW. Again, used to let's not compile from source because we already did it once and we kind of get it, and also it's annoying. So we're just gonna find the right package for us. Yeah, I want the binaries, as you can tell from the purpleness of this text. It's gonna be a bit slow. For that, I'm kind of a bit sorry, but not that sorry. Right. So we just download this. I heard SourceForge is people are boycotting it now because they're being dicks. Oh, are you serious? Are you serious? No. I literally downloaded this yesterday. No. What do we want? We want, God, 1.11, 1.12, whatever. Let's get 1.12. Looks popular. Min32 zip. Yeah. Why are these so much smaller? Maybe I should get the smaller ones. Man! What are we gonna do? Are we gonna have to compile from source? Is that what we have to do? Or should we get the TG zip? Why is it so much smaller though? Does anyone know? It's missing too. Oh, maybe it's moved to GitHub as well. Because a lot of people started boycotting SourceForge because SourceForge has been doing scummy stuff. SourceForge, source. Oh, man. I literally downloaded this yesterday. 1.12, January 26th. This is really annoying. Maybe the stream is like... No, I don't want to blame the stream. But in a way, I do want to blame the stream. Unable to find mirror information for glue 1.2. Please select another file. Well, we can get 1.1, right? But that might not be there either. I mean, 1.11. I can't imagine it's too different. Yo, what's up, stream? Hello! Hey, Osama said. Osama said, hello. Did that fail to download as well? Yeah. Okay, so glue SourceForge. What's going on? Glue SourceForge 1.7. Glue binaries. Maybe. No, this is just going to point to SourceForge again. SourceForge. Arc Linux. This is not going to be Win32, is it? Error building glue. You know, we might actually just have to fucking build it from source. Well, I mean, we know how to do that now, right? So, good. Yep, good. We do know how to build from source, so, I mean, let's do it. Let's do the right thing. Be a real man. Let me check this. Yes, they're still here. Awesome. Okay, great. Great. Let's put this here. Okay, so luckily I didn't delete it. Include libs. Yeah, this glue. Include, it's got nothing. Okay. So what about here? GL GL. Is there GL somewhere here? Oh, just drag it out there. Okay. Cool. So we've got. Yeah, these are the glue headers. Cool. So just trust me on this. I mean, I'm sure later on you'll be able to download glue somewhere, but right now I couldn't. So this is the glue static library, and these are the glue includes. And what we're going to do is we're just going to go to our friend, Mr. Includes. And people like to put it inside GL, so they put it like this. So in the includes, it's like that. And then libs is also GL. And then this guy goes in like this. And then what we also need to do is we also need to get this name and add it to our linker. Oops, wrong one. So we go here, properties, like that, and that should be great. Now let's read what's going on in chat. Are you good in Linux? No, I am not good in Linux. Yeah, that's right. I like Windows. Okay. Since glue, we will be using the static version of glue, which is glue32.lib. Notice the S for static extension. So add the library to your library folders and also add the include content to your include folders. We just did that. Then we can link glue to the project by adding glue32s.lib to the linker settings Visual Studio. We also just did that. Note that the GLFW3 is also by default built as a static library. Static linking of a library means that during compilation, the library will be integrated into your binary file. This has the advantage that you do not need to keep track of extra files, but only need to release your single binary. The disadvantage is that your executable becomes larger, and when a library has an updated version, you need to recompile your entire application. Dynamic linking of a library is done via .dll files or .so files, and then that's probably on Linux. I don't know though. And then the library code and your binary code stays separated, making your binary smaller and updates easier. The disadvantage is that you have to release your DLLs with the final application. People tend to do this quite a bit. I mean, when you install games, it just dumps a bunch of DLLs into the program files, like, the program files directory. If you want to use glue via their static library, we have to define a preprocessor variable, glue_static, before including glue. So this is just another one of these annoying things you got to do when setting up environments. Just this. And how would you know that? You could read glue's docs and they'll tell you, or like you could be lucky and the tutorial will tell you. But if not, you're just a bit fucked. If you want to link dynamically, you can omit the glue_static define, so just don't have that. Keep in mind that if you want to link dynamically, you also have to copy the .dll to the same folder of your binary. For Linux users, compiling with GCC, not relevant. Now that we successfully compiled and linked both GLFW, we're set to go. Did we compile and link? Did we successfully compile and link? I mean, we don't know, right? If we do a build, nothing happens because we haven't done a main. Okay, so I mean it succeeded, but we don't see anything. If you're still stuck, check out the comments. No, we're not stuck. So we're going to go to the next tutorial. And we might do one more after this one. Or maybe not. But this is pretty fun, doing these tutorials. Next one I might get a bit more stuck because I haven't done it before. Let's see if we can get GLFW up and running. First, create a CPP file and add the following includes to the top of your newly created file. Note that we define glue_static since we're using the static version of the glue library. Yes, I did note that in the last tutorial when you first mentioned it. Okay, so it doesn't tell us, it just says create a CPP file, but it doesn't say what to name it. From here we can kind of see it's probably a main file, and probably want to call it main. But that might actually be a terrible idea. I don't know. Not a CPP, so we're just going to copy this stuff. Glue #define glue static #include GL/glue. Let's do that again. GL/glue.h. Oops. And if you don't get something like that, or if you get if you get squiggly lines under that, you've messed up your linking, or you've messed up your include directories, or you messed up your lib directories. Or you just basically messed up the previous tutorial, where we were before. And if you are stuck there, you gotta fix it immediately. You gotta figure out why, because you just won't be able to proceed. So, yeah. GLFW. Don't these two acronyms look the same? Glue and gloof and gloof. Like, there's really only one line underneath. There's only one stroke missing from these two, so that's why I hate them. #include GLFW/ this one, I guess. That looks right. Be sure to include glue before GLFW. The include file for glue contains the correct OpenGL header for includes, like GL/GL. So including glue before any other header files that require OpenGL does the trick. Next, we create the main function where we would instantiate the GLFW again. So we just go into main, bang that out, and GLFW init, GLFW init, FW init. That's cool. So next is just 4 GLFW hints, and yeah. So I mean, let's actually type it out. FW window hint. Is that it? Yeah, it is. GLF GLFW window int. I'm just gonna make skeletons for these guys, and then so GLFW context version major, GLFW context version minor. So major is like the first number, minor is the second number. So it's basically saying, hey, I want to OpenGL 3.3 window, and if your computer cannot support OpenGL 3.3, then you can just fuck off. Basically, it's not going to run on anything less than OpenGL 3.3. And the reason for that is because this tutorial is about modern OpenGL. It's not about 1992 OpenGL or 1996 OpenGL. It's about like high performance, very cool modern GL, OpenGL, which I did not learn at university. I learned the old stuff. Okay, so GLFW context version major, GLFW context version major, and it's 3. GLFW context version minor, also 3. Yep. GLFW, it's really annoying in C and C++ programming that these names are so long. But what are you gonna do? OpenGL, oops. OpenGL profile is something, I don't know what it is. GLFW resizable. Resizable is also something. So this is GLFW OpenGL core profile. I'm not too sure what that means. I did read it yesterday and I've forgotten now. And this is pretty simple. Is the window resizable? No, it's not. Okay. And then the last line is return 0. So we can build this now. I'm sorry, my mistake. We cannot build this now. Why? 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 Okay, it failed to link glue32s.lib. So let's go into libraries. Yeah, why not? Oh, did we forget to type it in to the place with the linker? Linker. Glue32s.lib. I mean, it's there, right? Glue32s.lib. Cannot open file glue32s.lib. Yeah, I don't know. I don't know what's going on. Libraries. Glue32s.lib. They spell it wrong? Glue32s.lib. No. GL32, glue, GLFW 3.lib. That's right. Let's try and build it again. No. Build clean. Yeah. Still no. Any ideas, chat? I mean, you guys can help me as well. Thanks, Osama. I don't know what you thought was an excellent explanation, but I'm glad it was excellent. Can you give me an excellent explanation as to why this is not compiling? If you could, I would like that a lot. Why? Why? Glue32s.lib, right? Yeah. Yeah. Well, I mean, I feel like if we go here, if we remove it from the linker, it will compile it. We do need it later. 32 OpenGL 32. So let's remove it. Yeah. And then when we build, we can't find glfw3.lib. Right. That's bad. So obviously there's something wrong with our libraries folder. So let's check that out. So C++, B C++ directories, C++ directories libraries. Let's edit this. Let's edit this one. Let's kill it and add one. Did we rename it or something? What did we do? Libraries. Select. Oh, maybe they shouldn't be in. Maybe they should be in the root of libraries. And I don't know what that was about. So maybe they should be like just out in the open. Maybe? I don't know. That seems to be the problem, yeah. Yeah, okay, so headers, you can organize them, and libraries don't organize them. I don't know. I don't know what's the proper way to do that, but that's how I fix that problem. I'll try to find out. There's a really smart C++ guy at work. I'll ask him about it. So what was that called? glue32s.lib, I think. I think it was called that. Let's double check. glue32s.lib. These guys are empty. So let's kill them. I'm gonna just go apply and okay, and see if that works. Yeah, okay. So it's all compiling now. It's all building and running, but it doesn't do anything. Well, it's doing something, but I mean, it's meaningless to us. In the main function, we first initialize a glfw with glfw init, after which we can configure glfw using window hints. The first argument, window hints, how we want to configure. The second argument is an integer that sets the value of our option. A list of all the possible options and corresponding values can be found in this documentation section. If you try to run the application now and it gives a lot of undefined reference errors, it means you didn't successfully link the glfw library. Yeah, we kind of got through that, and if we fixed it up. Since the focus of this website is an OpenGL version 3.3, we'd like to tell glfw that 3.3 is the OpenGL version we want to use. This way, glfw can make the proper arrangements when creating an OpenGL context. This ensures that when a user does not have the proper OpenGL version, glfw fails to run. Like I said, we'll tell you to fuck off. We set the major and minor version both to 3. We also tell glfw we want to explicitly use the core profile and that the window should not be resizable by a user. Telling glfw explicitly that we want to use the core profile will result in invalid operation errors whenever we call one of OpenGL's legacy functions. Okay. Which is a nice reminder when we accidentally use old functionality where we'd rather stay away from. So it's basically like, it's like strict mode in other frameworks, in other worlds. Basically, if you're using older stuff and you set this core profile thing, it'll just crash. And then you should know, wait a minute, I shouldn't use this core, I shouldn't use that function call because that's the old way of doing it. Note that on Mac OS X, you also need to add glfw window hint, glfw OpenGL forward compat, gl true to your initialization code for it to work. No explanation for that, but who cares? Make sure you have OpenGL versions 3.3 or higher installed on your system hardware, otherwise the application will crash or display undefined behavior. To find the OpenGL version on your machine, either call glxinfo on Linux machines or use a utility like the OpenGL extension viewer for Windows. If your supported version is lower, try to check if your video card supports OpenGL 3.3, otherwise it's really old. Yeah, I don't think anyone's going to have that problem. I don't know what mine's on. but it's a pretty new computer. I got it at the start of this year, so I think I can't imagine anyone is running a computer old enough that you can't have GL 3.3. Next, we are required to create a window object. This window object holds all the windowing data and is used quite frequently by GLFW's other functions. So this object is going to be important. So let's just type in the code. It doesn't actually say where it goes, but you can kind of figure it out before returning 0. Because if you write code after here, I mean, nothing happens. It doesn't even, it might compile, I don't know. GLFW window star, pointer to that window equals. I think it's actually like this. It's a bit weird. Or it's like this. Yeah, it's weird, isn't it? Here goes GLFW create window. And 800, 600. Learn OpenGL. No pointer. No pointer. If window equals no pointer. I'm just gonna do this because I'm a dick. GLFW window terminate. GLFW is just terminate. Return -1. What do they want? So failed to create a GLFW window. Failed to create a GLFW window. And then we also want CDI of H. The GLFW create window function requires the window width and height as its first two arguments, respectively. The third argument allows us to create a name for the window that's there. For now, we call it learn OpenGL, but you're allowed to name it however you like. We can ignore the last two parameters, so we just pass in nulls. The function returns a GLFW window object and will later need for other GLFW operations. After that, we tell GLFW to make the context for our window in the main. So this is error handling, this whole chunk here. So it's like, make a window, and then if for some reason that window is null, as in it failed to create, then output a message, do this GLFW terminate, which just cleans up, and then return -1, which is like standard application failed message. Okay, glue. In the previous tutorial, we mentioned that glue manages function pointers for OpenGL, so we want to initialize glue before we call any OpenGL functions. Glue experimental equals GL true. Ooh. So that we're going to be doing some experiments. Glue init does not equal glue. Okay. How come glue gets its own, like, why is it okay? Why not true? Look at this, okay and no error. I could use either one. There's a really funny error message in Win32. I think it's error success. It's like a Microsoft thing. Yeah, look at this. It's like error success. The operation completed successfully. Good name. Anyway, where were we? Here. So it's the same sort of thing as before. You just want to call this. So actually, like, it's one line. Oh, 2 lines. And then here it's 1 line as well. Oh, we forgot this thing. GLFW make context card. GLFW make context card. And pass in the window, which we created up here. Alright, back to this guy. So same thing. We call glue init. If that failed, if it does not equal glue okay, as in if it failed, then output error message, return -1. So printf error message, return -1. He actually doesn't do the GL terminate thing, and I think you should. It's just cleanup. I think you just forgot to do it, or maybe there's a good reason you didn't do it in this tutorial. And why am I writing printfs instead of this stuff? Because they're shorter. I mean, how much easier it is to write a printf as compared to like this nonsense. We need new line characters. So yeah. Notice that we set glue experimental variable to GL true before initializing glue. Setting GL experimental to true ensures glue uses more modern techniques for managing OpenGL functionality. Leaving it to its default value of GL false might give issues when using the core profile of OpenGL. Yep. Just legacy shit. Before we can start rendering, we have to do one last thing. Actually, like he says that. But as you can see, there's more stuff. See, look, one last thing, and then one last thing. Come on, man. That's like, it's 3 last things. I have to tell OpenGL the size of the rendering window so OpenGL knows how we want to display the data and coordinates with respect to the window. We can set those dimensions via the GL viewport function. Yep. So, doesn't say where, but it seems like this is the right place to put it. Viewport 00 800 600. It's basically the same. It's a window we create. The GL viewport is the same. It's 1-to-1, basically. Behind the scenes, OpenGL uses the data specified via GL viewport to transform the 2D coordinates it processed to coordinates on your screen. For example, a process point of location -0.5, 0.5 would, as its final transformation, be mapped to 200, 450 in screen coordinates. Note that the process coordinates in OpenGL are between -1 and 1, so we effectively map from the range -1 to 1 to 0 to 800 and 0 to 600. Yeah. Ready your engines. We don't want the application to draw a single image and then immediately quit and close the window, which is what it does at the moment, actually. So, bam, window and then close. Because it's just like, it makes the window and then just exits. So we want to add in like a infinite loop, and that's basically what he does. Doesn't look like an infinite loop, but, well, it's not, but it's just like a loop. We don't want the application to draw a single image and then immediately quit and close the window. We want the application to keep drawing images and handling user input until the program has been explicitly told to stop. For this reason, we have to create a while loop, and we now call the game loop. That keeps them running until they tell GLFW to stop. The following code shows a very simple game loop. So let's just type it up. While not GLFW window should close. GLFW window should close. Window. GLFW poll events. GLFW swap buffers. Window. So now, when we run, the window stays open. Yay! So we've actually done, we've made a window, right? So, you know, that's great. We've achieved our objective. We did it all from basically nothing. It's not that much code, but we dicked around a lot with libraries and header files and SourceForge and other assholes. So it's not much, but it's still cool. I was pretty happy yesterday when I got this going. I'm still pretty happy to get it again today. Less happy, but still pretty happy. The GLFW window should close function checks at the start of each loop iteration if GLFW has been instructed to close. If so, the function returns true, and the game loop stops running, after which we can close the application. The GLFW poll events function checks if any events are triggered, like keyboard input or mouse movement events, and calls the corresponding functions, which we can set via callback methods. We usually call event processing functions at the start of a loop iteration. I'm gonna stop saying GLFW. The swap buffers will swap the color buffer, a large buffer that contains color values for each pixel in GLFW's window that has been used to draw during the situation. This is just an explanation of double buffering. It's not important. You can read it yourself. I don't want to read it. I'm getting tired of reading. As soon as we exit the game loop, we would like to properly clean / delete all resources that were allocated. We can do this via GLFW terminate function that we call the eliminate function. So it's just something we've called a few times actually. We call it before exiting. It's just cleanup code. It's C++. It's just the annoying world of C++ where you have to do everything explicitly. If you forget to do this, there's a chance that you can leak memory, and that's very bad. Not as bad as it could be, but still it's bad programming practice. And on some platforms you can like kill the whole platform by leaking memory. Like a low memory device or something, like an embedded device or something. If it's a very dull and boring black image, you did things right. If you didn't get the right image or you're confused as to how everything fits together, check the full source code here. Yeah, so you guys can, I mean, we can click on this, take a look. It should look exactly the same as what we got. It's the same, he's got comments. And he's not using printf. Yeah, cool. And then he did this. I was thinking about doing this actually. You bastard. It's basically he's using width and he's using const values instead of typing them in. Should we do that? Yeah, let's do it. Oops. Width height. If you have issues compiling the application, yeah, well we didn't, because we're pro. We don't have any problems. Just nail it the first time. Great success. We also want to have some form of input control in GLFW, and we can achieve this using GLFW's callback function. So callback function is basically a function pointer that you set that GLFW can call at an appropriate time. One of these callback functions that we can set is the key callback function, which should be called whenever the user interacts with the keyboard. The prototype of this function is as follows. Yeah, so we're going to make this callback function. It's key callback, and it's basically responding to input. Like more specifically, it's like after input's checked, this function calls the library, the OpenGL or Glut or GLFW or I don't know, one of these jerks is going to call your code. So you pass off to the library and then the library calls back to you. That's why it's called a callback. It's like a way of injecting code into libraries, your code. It's supposed to be safe. Void key callback, GLFW window, oops. Star window, int key, int scan code, int action. I don't know why these are ints instead of GL ints. I don't care either actually. For like they say for best practices you're supposed to always use GL stuff, like the GL version of ints and floats and bools and you know all this stuff. Now, if you look at GL float, right, it's actually just a float. The reason you do it is on different platforms. Yeah, I really don't know why you do it. But it's like a cross-platform support sort of thing. I don't really get it too well. I mean, I've never made a cross-platform OpenGL game, so in C++. Key callback. So I'll just trust these guys when they say they need to do it, but I don't know why he's not doing it here. Maybe because it's not OpenGL code. I don't know. int key, int scan code, int action, int mode. Alright. Yep. Let's just copy this comment. I don't want to type it. When a user presses the escape key, we set the Windows should close property to true, closing the application. So what does it do? If you press escape, we close the application. That's it. glfw escape. Key escape. And action equals glfw press. He doesn't have these braces, but I'm going to put them in because that's my style. glfw set window should close. Window gl true. Why is this gray? Why is this gray? Why are these things gray? I don't know. Don't know. Maybe it's because... who cares? In our newly created key callback function, we check if the key pressed equals the escape key, and if it was pressed, not released. We close glfw by setting its window should close property to true. Using the glfw window should close. The next condition check of the main while loop will then fail and the application closes. The last thing to the left to register the function with the proper key back callback via glfw. Yeah, so we want to set this. Obviously, that is going to be set before the loop. glfw set key callback. glfw set key callback. And it's window and then key callback. That's it. There are many callback functions we can set to register our own functions. For example, we can make a callback function to process window size changes, to process error messages, etc. We register the callback functions after we've created the window and before the game loop is initialized. Yeah, so after we created the window, before the game loop is initialized. Because if we did it after here, like, it's just never gonna... this code doesn't run. So we're in the game and this callback's never set. Rendering. We want to place all the rendering commands in the game loop, since we want to execute all the rendering commands each iteration of the loop. This would look a bit like this. Check and call events, rendering commands here, swap the buffers. Program loop. No, game loop. Check and call events, swap the buffers. And then what? Rendering commands. Here. I like it how he actually puts a space like that. It's pretty nice. I can dig it. I can dig it. Oh, actually, I don't like it. Yeah, whatever. Let's just go with it. It's not bad. Just to test if things actually work, we want to clear the screen with the color of our choice. At the start of each render iteration, we always want to clear the screen, otherwise we would still see the results from the previous iteration. This could be the effect you're looking for, but usually you don't. We can clear the screen's color buffer using the glClear function, where we pass the buffer bits to specify the buffer we would like to clear. The possible bits we can set are glColor buffer bit, glDepth buffer bit, and glStencil buffer bit. Right now we only care about the color value, so we only clear the color buffer. Yeah, the upshot is we're just going to clear the color, set the clear color, and then clear. Yeah. Yeah, so we're setting the clear color, and then we're running the clear. Set, run, set, fill. It's like saying, okay, the color's green, and now paint everything green. That's what these two tricks do. So let's just Let's just add it. GL clear color 0.2f, 0.3f, 0.3f, 1.0f, and then GL clear, GL color buffer clear, right? And some more stuff, blah 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 blah. But that's basically the end of the window stuff, and it's green. And we can do something a bit fun. Should we? Should we do fun things? 0, 0, 0. This will be black. Yep. And then, oh yeah, the other thing is if we press escape, it closes. Maybe I'll show you guys. There's the escape key. Press it, it closes. And just to prove to you guys it works, we'll comment this out. And so now, press escape, nothing happens, right? This still works, but the key stuff doesn't work. And we can change that to some other keys if we want, but really, who gives a shit? We can set this to white, like this. It's white. Oh, there's no reason to show you the keyboard. And we can also do something fun, like you can get the color to pulsate. So what's a nice color to pulsate? I guess red is nice. So GL float red value equals 0.0. Does that work? Why is that unacceptable? What? Does anyone know why that's not okay? Can anybody tell me? Can anybody tell me? Can anybody tell me what's wrong with that code? GL float. Maybe that's not the right way to do it. GL float. Oh, it's like this, right? Right. So that was actually, yeah. Okay. That was something else. I don't just. That was a value, not a type. Okay, so the red value is this. We'll pass in red value here. Right? But what we're going to do is every frame. We'll also do this like GL bool. Boolean going up equals true. Right? And then we'll go like this. If going up, red value plus equals 0.001. Yeah, right? Else, red value plus minus equals 0.01f, right? And we can also do this. If red value, oops, wait, that's red value greater than or equal to 1.0f, then going up, which is false. Right. Well, maybe. Does it have to be GL false? That is really annoying, isn't it? That is so annoying. Yeah. And then this code's a bit ugly, but who cares? It's just like a little experiment. I told you guys we were gonna do some experiments, and we are. Let's say equals to 0.0. Going up equals real true. Okay, so who is smart enough to figure out what that does? And also, is anybody watching my stream? No. Alright, I'm not gonna ask you guys. I'm just gonna tell you what happens. So we set two values, a float and a boolean, right? And if it's going up, we increase the red value by a small amount. If it's going down, we decrease the red value by a small amount. And if we're going up and the red value is above 1, then we start going down. And if we're going down and the red value is less than 0, we start going up. So it's just like the red value goes up and then goes down. It goes up and goes down. And the red value is used to set the color of the window. And so we should get like a cool little effect. Didn't work. Yeah, that did not work at all. Well, something's happening. Maybe it's not. It's red, green, blue. Ah, yeah, okay. So it was pulsating, but it's kind of moving a bit too slow. So let's drop one of those zeros. And then, oh yeah, okay. So let's try it now. So yeah, that's kind of what we wanted. I'd like it to move a bit faster than that, actually. Maybe 0.5. Yeah, cool, right? So now we have like, now we can safely call this a game. This is a video game. It's not. I would not play it, but it's cool. Ooh. Somebody just told me bitcoins are up and I should buy them. Yeah, so that's basically that. You can change this to blue value as well. Can we do a refactor? No, we can't. That's really annoying. Ah, that's a bummer. So we could just move this 0.0f, and this is green, and this should, yeah, make a pulse green, and then we can also add it here. It should make it pulse like light blue, and then this will just make it pulse blue. Yeah, so it's pretty cool. Yeah, so that's the GL window tutorial. I think we'll leave it here. Oh, we don't want to see that. I want to go to the next tutorial. So, yeah. Thanks for watching, guys.